Hey everybody, this is Larry. This is day 14 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Delete the middle node of a linked list. I assume you're not given n. And of course, the easy thing is just to count out the n and then just go again and delete the middle. And it's just a regular delete node test thing. But yeah, I'm just looking for the follow-up or whatever, but there's no follow-up, but that's okay. We don't need a follow-up. The follow-up is, can you do it in one pass? And here, the tricky thing about, or I don't know if it's tricky, but the weird thing, if you ask me about passes, is that, I mean, I've kind of talked about passes in the past on this channel, so some of this may sound very familiar to some of you. I apologize. Feel free to fast forward or whatever you need to do. The thing with passes is that the reason why you want to have as few passes in general, especially in an array situation back in the day, is because of memory locality. And memory locality, of course, will allow you to, take advantage of cache hits and different lower level caches, right? And most of the time when you're doing these things, depending on what you're doing, I suppose, but if you're doing linear time things, a lot of your especially when your n gets bigger, I always usually your blocking situation, right? So anyway, so the point there is that a lot of your time is going to spend on memory and stuff like this, right? So two things. One is that if you use a linked list, obviously you kind of already lose that memory locality thing, right? You may record that in an array, and this is all off my head, by the way. I'm not prepared for this, so it's just that I feel like this is something that I don't know. So yeah, so I may be wrong on certain things. So definitely, if I am wrong, because this is off my memory and off my brain and off my experience, leave a comment in the comments below. But yeah, in a linked list, obviously the memory is not going to be contiguous, or even if it is, there is just more overhead anyway, so you can fit fewer items in a certain cache. But of course, if you are able to do things like delete the middle node, at a certain point your memory will get defragged anyway, or fragmented anyway, and you want to defrag it. So that's one. So there is still some benefit in having one pass instead of two pass, because then now, even though you're not taking advantage of cache, you're also not jumping around and memory accessing as much. But it's not as important. Of course, with all things that are talking about low level performance, you have to benchmark, and of course in those world you're probably not using Python, but that's besides the point. Anyway, I just want to kind of do my little rant on the passes and how little it matters, if you ask me. But cool. So yeah, so the thing here is, to the middle node is really just, and they tell you this, is just n over 2 node, right? So if you have basically, and this is I hesitate to call it a trick, but it is something that you like with a linked list. They're really, I mean, I used to hate linked lists. I still kind of do, because I don't really care for them. So I don't hate them per se. I just don't care for them. And there are only like a couple of things, right? One is just using the fast slow pointer thing, some variation of like Freud's algorithm or something like this, especially for the loops. And yeah, and that's really the way to do it, right? And yeah, though yesterday I was a little bit sloppy, or not sloppy, I just didn't think I didn't think there was an over 1 to be honest. If someone had said like, hey, there's an over 1 solution, I might have gotten it. I don't know. Now I'll never know whether I could get it, right? Like now that I know the answer, I know the answer. Though maybe in a year, if they give that question again, I might forget by then. But then someone has to tell me that, oh, 1 solution exists again. So I don't know. The point there is that there are only a couple of techniques that comes up often. And here, the slow fast pointer is one of them. And of course, in this case, the motivative factor is going to be 2, because you want n over 2. So maybe there's some variation there. There's also some funky things like skip list and stuff like that. That's kind of tangentially related if you want to play around with those things. Not for this problem, just in general. So yeah. So anyway, so now let's get started. The one thing that I am very bad at, to be honest, is off by ones. So especially with stuff like this. So let's say, you know, the first thing I always do is just have a sentinel. I call it new head. I don't know if that's like a good thing for it, but yeah. And then I have a fast as you go to new head, and then slow as you go to new head. Otherwise, we just kind of move it up, right? So while fast is not none, it's either fast or fast done next. I have to think about this a little bit. But basically, you know, okay, well, we can probably draw it out a little bit because, or like, we can go through the cases. I'm just a little bit lazy. And that's how I would do it if I was in an interview, especially, where I could be like, okay, well, the fast moves 2, the slow moves 1. Is that the right one, right? And in this case, I don't think so because if you have 2 nodes, you actually want to remove the second one because it's n over 2 plus 1 or whatever it is. Yeah, and there's some like weird indexing actually for even numbers. So yeah, so maybe we have to play around with that, but the idea is still going to be the same. So of course you have to do another if statement, but that's fine. And also the autocomplete is really annoying to me if you can't tell, because it like also eats my enter key, so like it's slowing me down. Okay, so then now we want to maybe we move slow, but we could just also print it out really quickly, just to kind of see, you know, if it matches our expectations really quick. It doesn't really matter. So this prints out 7, that's good. This prints out 3, that's also good. Prints out 1. So actually we're pretty good, right? We only have to, well, we're almost pretty good because now we know that slow is the one that we want to remove. So then we want to have the previous pointer that removes the slow, right? So that you can skip it. You can do things in a couple of ways. I'm lazy, so I'm just gonna add a other one. What, you know, memory is cheap. Operation 1 or 2 operations is very cheap. So let the computer do it for you instead of doing some like funky arithmetic-y thing. So yeah, so right. So then now prev.next is you go to prev.next.next, right? I think that should be good. Where's my button? Oh, I moved it to the left somehow, huh? Okay, well, it's not so good if you get a wrong answer. What? How did that? Oh, I have to return the thing. Okay, I didn't know if this was a return the because this UI sometimes is buggy. Oh, there you go. What I typed, but I can't edit this. I'm just banging on it. Oh, there we go. That's weird. This UI is weird. Oh, what the? And now we just have to return new head.next. That's basically the head of the list, I suppose. I just, you know, as I was going to say before the UI screwed up. Where did I type that? Oh, there it is. Because I was just banging on the keyboard. Anyway, the UI is a little bit wonky. Let's give it a submit. But what I was going to say before, now I've totally forgot what I was going to say. Oh yeah, I was just going to say something like a lot of these problems. 927, nice. A lot of these problems. A lot of these problems, they either, you know, sometimes you return it, sometimes you just do it in place. So I can never tell. But yeah, but this is pretty okay. Yeah, this is going to be linear time, constant space for 3 pointers and 4, I suppose. And that's pretty much it. Yeah, you can do it with 2 loops as well. I don't care about it. These problems are kind of silly. But, you know, what I would say is practice for what you want to practice, right? Don't, you know, solving a problem doesn't matter. Or like, you know, the problems count. Who cares, right? Like solve it or work on how you want to improve, right? Not just solve the problem. Like, you know, I could put in like a crazy way of doing it, which sometimes I do, to be honest, to avoid off by 1, is I would convert it to an array and then delete the middle number and then convert the array back to the linked list. Yeah, does that solve the problem? Do you get a one solved thingy? Sure. But, you know, do you get any better at linked lists? Probably not. So yeah, so that's up to you. I don't, you know, for the interviewer, I don't know, these things, if you are in an interview, then just communicate a lot and talk about what you're doing and what you're trying, and that's it. Yeah. That's pretty much all I have for this one. So let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.